guys, welcome to our very first video in our chemistry/physics YouTube channel. So most of you have been following our videos in mathematics and further maths in our other channels, so maybe some of you are just joining us now, you don't have any idea. So nevertheless, I'm going to drop a link to the mathematics and further mathematics channel, so you can get there and you follow the videos, you subscribe to the channel, you turn your notifications. For those of you who are just joining us now, please endeavor to subscribe to this channel. Like I said, it's our very first video. After subscription, endeavor to also turn on your notifications, so that when we upload the videos, YouTube is always going to notify you to come and watch the video, or to be updated that okay, this channel has uploaded this video, so you have a fixed program that I'm going to watch this video this day, and so on and so forth. Alright, so in this video we begin with chemistry. We are going to solve June 2022 chemistry paper 2 section A, question 2a. So the question is on mole concept, and we are going to go through the question together. So when I display the question, endeavor to solve the question on your own, get your responses, and then now watch the video to see if your responses were correct or weren't correct, and you learn where you went wrong. Okay, so let's get started. Alright, so here is a question. It reads: a standard solution of a 0.18 mole per cm cube sulfuric acid was prepared. 21.6 cm cube of the solution neutralized 25.0 cm cube of a sodium hydroxide solution. On evaporation and weighing, 0.30 gram of the salt sodium sulfate was obtained. Roman 1. What is a standard solution? Roman 2. Calculate the molarity of the sodium hydroxide solution. Roman 3. Determine the mass of sodium sulfate expected. And Roman 4. Calculate the percentage yield of the reaction. So the question was allocated for 6 marks, and you see this section here, right? I'm going to, whenever I answer a question, I'm going to tell you how many marks that question is allocated for. Though on your paper, the 6 marks is just written at the end of the question, actually for this question, but the Cgce marking guide, the marks allocated for every sub question is indicated, so that's what I'm going to be giving you. Alright, so first, what's a standard solution? Very basic. A standard solution is a solution whose concentration or whose molarity is known. Doing that, you have 1 mark. Now, woman, to calculate the molarity of the sodium hydroxide solution, firstly you write your chemical equation for the reaction, and next you balance. So this is a chemical equation. You have sulfuric acid, which neutralizes sodium hydroxide. It's a neutralization reaction, so you produce salt and water only. So you now need to balance your equation after writing. So you balance sodium by putting 2 here, and then you balance hydrogen and oxygen by putting 2 in front of water. So with that, you get 1 mark for doing that. Now, since you need to get the molarity of the sodium hydroxide solution, and it is an acid-base reaction, you go ahead by giving a relationship between the molarities and the volumes and the number of moles. So the molarity of the acid times the volume of the acid divided by the molarity of the base times the volume of the base should be equal to the number of moles of the acid in the balanced chemical equation divided by the number of moles of the base in the balanced chemical equation. Now, that was the essence of balancing your chemical equation, so that you get your number of moles of the acid and the number of moles of the base. Now, from your balanced chemical equation, you can deduce the number of moles of the acid to be 1, because you have 1 mole in front of the acid. And what about the base? You have 2 moles in front of the base, which is sodium hydroxide. So with that said, you can get the molarity of the base by making it the subject of the formula. So your B here is 2 and your A is 1, so your molarity of the base will be equal to, you cross multiply, right? So you have 2 times the molarity of the acid times the volume of the acid, then divided by the volume of the base. Do we have the molarity of the acid? Yes, it was given as 0.18 mole per cm cube. Do we have the volume of the acid? Yes, it was given as 21.6 cm cube. What about the volume of the base? Yes, we have it. It is 25.0 cm cube. So all you need to do is to replace those values. Your final response is going to be in mole per cm cube. You use your calculator and you get your molarity of the base to be 0.311. That's an approximate value. You might have something else. Maybe you depending on your number of decimal places, but I approximated to 0.311 mole per cm cube. So doing that, you get 1 mark. So Roman 1 is 1 mark, Roman 2 is 2 marks. The 2 marks come from first your balanced chemical equation, and next your calculation with the right answer. You get 1 mark. Okay, Roman 3 is asking us to determine the mass of the sodium sulfate expected. Remember, the sodium sulfate is our salt that was and we need to get the mass that was expected. But if you come back to your question, you see that they throw that on evaporation and weighing, you obtained 0.30 gram of the sodium sulfate. That's actually what you actually obtained. But we need now to calculate what you expect. So how do we proceed? First, we need to calculate the number of moles of the acid, which is the molarity of the acid times the volume of the acid. Why? Because we know that the molarity of the acid is the number of moles of the acid divided by the volume of the acid in cm cube. So with that, we have the molarity of the acid, which was 0.18 mole per cm cube. Now the volume of the acid was given in cm cube, and to change it to dm cube, we divide by 1000. So simplifying, you get this 0.0039 mole of the acid. What about the number of moles of the base? The number of moles of the base is the molarity of the base times the volume of the base. We have the molarity of the base, which we calculated previously. And what about the volume of the base? It was given in cm cube, so you need to divide by 1000 to take it to dm cube. At the end, you get your molarity of the base to be this. Now you might be wondering why we are doing this. We are simply doing this so we can get what we call the limiting reagent. What's the limiting reagent? It's a reagent which is completely used up in the chemical reaction. Now we know that according to our equation 1 here, we can use our mole proportions. We know that 1 mole of the acid produced 1 mole of the salt. So it means that 0.039 moles of the acid will produce how many moles of the salt? From the moles of the salt, we can get its mass. Since we know the molar mass. We know the moles is equal to the mass divided by the molar mass, right? So that's why we are doing. But what about sodium hydroxide? We could also use sodium hydroxide to get it. 2 moles of sodium hydroxide gives us 1 mole of the salt. It means our 0.078 mole of sodium hydroxide is going to give us how many moles of the salt? We get the moles of the salt, and then from there we multiply with the molar mass to get we multiply by the molar mass to get the mass of the salt, which is what we are trying to determine. But now there's a confusion. Which one are you now going to use? So that's the essence of doing this. We need to get a limiting reagent. So like I defined, the limiting reagent is a reagent which is completely used up in the chemical reaction. And how do we determine it? We find the number of moles with respect to our information.